All right, solve triangles using the law of sines. So you've seen you've seen sines and cosines and tangents before. That's typically only when you have a right triangle, which is an angle of 90 degrees. Not every triangle has an angle of 90 degrees. So we're going to deal with triangles that don't have a right angle. And we're going to try and figure out other dimensions of that triangle. One of the ways we can do that is using the law of sines. So I want you to copy this down. So pause the video and copy all this down somewhere. You'll notice that angle A is opposite the side of A. So whenever I ask you what this is associated with, it's always the side right across from it. Angle C, side C. Angle B, side B. And the equation down here, you can see A is over A, B is over B, C is over C. The thing that matters the most is that wherever you have your angle, if your angle is in the bottom, it needs to be the same all the way down. I could rewrite all of these as the inverse, or reciprocal. Sine of A over A. And then we have a line here. And then we would have sine of B over B. And then finally, we would have our C. And it would be sine C over C. So either of these two will work, okay? And we're going to go back and forth to both of them. We want whatever our unknown is to be in the numerator, which is the top. So let's go to the first question. I have it written down right here. We're trying to find BC, which is this side right here. So it's associated with the angle directly across from it. So I have them color-coded. So one thing I told you, we want to have our unknown, our variable, in the numerator. So I'm going to use this top row where our side is in the numerator. So x goes in the numerator over sine of 38. And this is equal to another relationship. Well, we have 80 and 14. Well, remember, our degrees need to stay in the bottom, so that's going to go in the bottom. So sine of 80, and our side is on top. So we have side, side, both in the top. Angle, angle, both in the bottom. Now we want to solve for x. To do that, we need to multiply both sides by sine of 38. And these will cancel out. What we have left over is, I'll write up here, x is equal to 14 over sine of 80, all that times sine of 38. So, we'll go to our calculator and type it in. So clear it out. We have 14 divided by sine of 80, close the parenthesis out, times sine of 38, and close the parenthesis out, equals 8.75. The question asks us to round it to the nearest tenth, so we need to round our 7 up to an 8 because this is a 5. So 8.8. Okay, next question. Question 2. Find measure angle A, which is the guy down here, and round to the nearest degree, so whole number. All right, so here is the triangle drawn. We're trying to find measure angle A, which is opposite of 5. So we want our variable to be in the numerator, so we're going to do sine of x, because that's an angle, over its associated side, and that's equal to our other relationship. Well, what is on top? Remember, our angle's on top, so sine 28 over our side 7. Now, we want to multiply both sides by 5. So that cancels out. So then we have sine of x is equal to all of this. So x is not by itself. So what we need to do is take the inverse sine of both sides. So to get our x by itself, we do sine -1. Oops, So you can see that there now. And same thing over here, sine -1 of all of that. And when you do this, these cancel off, and we're left with x is equal to sine -1 of sine 28 over 7 times 5. So we can do that in the calculator. We start with the inverse sine, so we can do second, and the inverse sine is right behind sine. It's kind of hard to see. We'll zoom in a little bit. So here's inverse sine, and then we're going to type in sine 28 divide by 7, and finally multiply by 5. Ooh, and I made a mistake here. You can see my sine 28, I didn't close it out. I need to do sine 28 parentheses, then divide by 7, and then finally multiply by 5. And that all equals 19.59, and it said round to the nearest degree. So we're going to round up to 20 degrees. And right.